Hello and welcome to today's daily Leetcode challenge. Today we'll be solving question 1424, diagonal traverse 2. So, given a 2D array, nums, return all elements of nums in a diagonal order as shown in the below image. And this is the second version of this problem. The first version, I presume, doesn't have these blanks in here. However, we can still reuse the same approach from the original problem where the blanks aren't there, which was actually in example like 1. In example 1, there are no blanks, and what you would do there is you would be able to traverse it diagonally by keeping track of the row and the column simultaneously, and as you're incrementing through the different diagonals, instead of adjusting the row and the column one by one, you're actually adjusting the difference of the row and the column by one. So you would do something like if row 2 column 0, you would then have the next step would be row 1 column 1. So from this point it's going to be row minus 1 column plus 1, and then again row minus 1 column plus 1. That puts you at row 0 column 2. Anyway, well, with that out of the way, how do we go about the second version of this problem, which has these blanks in it? Well, what I think of right away is what is the commonality between each elements or each indices of these elements in a diagonal. And the answer to that is pretty quick. It's actually just the sum. The sum of the indices of row and column along the diagonal are all the same. So for example, in the orange here, we have the sum of 0. In the gray, we have the sum of 1, because 0, 1, and then 1, 0. In the blue, we have a sum of 2, because 0, 2, 1, 1, and 2, 0, and so on and so on. What you see here in this example is the same approach. We have the sum of the indices similar along the diagonals of the same color, right? Along elements in the diagonal of the same color. The 1 has its own sum, the grays have their own sum, blues have their own sum, yellows, greens, bright yellows, reds, grays, and pinks. That set aside, we are now kind of figuring out slowly which intermediate data structure we should use in order to traverse elements with some similar property. In my opinion, a dictionary here would serve its purpose very well. The key could be the sum. The value could be a list of elements that have that same function or property. And then yeah, from that point on, everything else is pretty simple. I think this rough start gives us a good direction to how to solve this. There are other approaches to this, I believe. Another one is that you could maybe create a set of all the possible indices that actually exist in the input, and then go with the diagonal traverse 1 approach, where you're simply just doing that thing that I told you before, and then if index is not in the input, then you just return. But this approach that I just talked about before is more straightforward and actually going to be faster, because we're not traversing over elements that don't exist in the input. So with that out of the way, because the constraints are huge, I'm going to go with the first approach that I told you and not the wrong second one. And we're gonna start this. I'm going to have a nums dictionary, which is a default dictionary with the default value of a list. For I in, let's say I and num in numerate nums, rate nums, I'm going to say for j in num r. For j in num r, I'm going to say nums dict at I plus j, append the value, which is, what is going to be this value? Should I just num enumerate? Ah, boy. Cool. Num. What did I just do? Well, I just created that intermediate data structure that I was telling you about, where the key is the common property of all elements along the diagonal, and the value is an array of elements that fall into that one property. If we were to print this right now, nums dict, we would see that we are very close to the finish line. We are, dict. We're very close to the finish line because we have this structure that we just need to, yes, default dict. Oh, I misspelled it. Because now we just need to traverse this default dictionary in a proper way. Let's look at case number 2. That is more interesting. We have the 0, the sum, and the 1. We have the 1, 6 and 2. We have for the 2, 3, 7, 8, 3, 7, 8. Oh, we actually have to reverse them too. Then for 3, we have the 4 and the 9, 4, 5, 10, 12, 5, 10, 12, then 11, 13, 14, 15, 16. Cool. That's it. All we need to do now is just have this, this reverse thing for, let's say, sum for nums dict keys. And then we are going to say that res extend nums dict of s, and we also need to reverse. I believe it's reversed. There we go. Return res, and we should be set. This was another nums dict. Oops. I don't know why that happens. Sometimes these mistakes come out of nowhere, and I really don't know what's up. Yeah, these sort of questions, I don't know why they're medium, but they do the job, and cool. I mean, we're in the 44th percentile, not bad. Let's look at what other approaches do. They have the DQ, pop left. This is actually probably the same approach, except instead of reversing the list, they do a DQ. Not interested because it's the same idea. Pop left. Yeah, all of these seem to be, yeah, they're all doing the same thing. They're all using the sum of the diagonal as a key value to find that common property. So in that case, I will suggest you use this approach. It's very clean, straightforward, and easy to read, and that's always what I try to go for. It is just a great solution, and applicable to all types of different problems, not just specifically this one. And the mentality is also the same. Find a commonality of the something that you're trying to find, and then put it all into a data structure, and then parse it. Okay, well, with that, thank you for watching. I'll see you guys later, and please like and subscribe because it really helps out the channel. Thank you. Bye.